Hi, my name's Bob Grenier, and I'm a volunteer with the Martin Fleischmann Memorial Project. So thank you for joining me again on this 12th November 2023 for Thor Outside Inside. And what you are looking at on the screen there is the inside surface of the outermost sphere of the Malcolm Bendel thunderstorm generator that was attached to the Perkins multi-100 kilowatt generator that was sited in Melbourne for 8 years, doing hundreds of hours of testing over those 8 years. And so when I saw this, I was very, very excited. Because what you're looking at on the screen there is the semi-regular array that we have seen in other systems, such as the Sapphire project, the Henk Uren and David Boutlier MFMP Vega experiments. And as I described on Friday, when we looked at the outside of the inside sphere, where we saw these markedly different structures, not in terms of having a semi-regular array of them, but in terms of them having this darker inner portion, this lighter ring, and then these much smaller like structures in the sea in between. And the difference between this, which does look irony, oxidey type thing with possibly something else going on that's making the white marks, and this, which is very black, and it's, in this case, it was illuminated with the macro lens on the Canon camera, captured in 4K, but the lights are extremely bright, and by using these extremely bright lights on the macro lens, it brought out the contrast between these two areas, the light in between and the dark areas. It is exactly the same camera used here for the outside of the inside sphere and here for the inside of the outside sphere. So what, pray tell, can cause the outside of the inside sphere to look so extremely different to the inside of the outside sphere? So I'll leave that question with you, and I will say hi to Shanyak, Corky Goss, D2105K, Martin Kemp, Creating Awareness, Estionias, Green Hiker, Maritime Slave, Geomatrix 999, Adonis, CC, great to have you here. So we had about 38 people on the aborted stream earlier. Hopefully some more of those can join us in the coming moments. So again, recapping what we did on Friday of this week, we observed that these structures on the outside of the inside sphere looked remarkably Okay, are we back in the room? I lost the connection again. I don't know, this is like extremely unusual. There was a similar thing earlier. Yeah, rare condition. The pitch shifting was due to choosing 41 kilohertz instead of 48 kilohertz on the audio. So can you hear me now? Okay, great. Hopefully this won't happen again. I reset the routers and so on, and it's connected on wired and wireless. Thank you very much for hanging in there. I really will just plow on as if you're listening to me if something else goes on, because I am recording this locally and I can just chop it up and upload it later. I just do like the questions from the crowd and being able to respond to them. So we have 20, so I think that's probably good enough. 20 dedicated to watch this terrible stream. Okay, so what I was saying was the work of Matsumoto from the early 1990s in his 1-point cold fusion. He witnessed these kind of marks on a copper witness plate in an electrolyte sparking, so you will have HHO in there and so forth, and high energy discharges. And a close-up of that looked something like this. Unfortunately, the camera was moving around a bit, so you have some multiple frames merged together here with some sort of directional blur. So do not read too much into this. Other than these crystallites, which seem to be well attached to the material. And this thing that suggested a kind of hexagonal shape, at least in this particular unit and potentially over here. Okay. So, sorry about earlier. These things sometimes happen. Let's hope they don't happen again in this stream. Hopefully to give some time to let others into the room. Essentially, we've got quite a lot of things exciting going on. There's a lot to talk about with the Wintex. I didn't get to review the material, but you can go to wintex.com and you can see the latest work that was done by Tony Yaboni. I probably will do that next week. Early next week, a delegation will be going to China to demonstrate Amasa gas, and I have been asked by the former head of Hokkaido University to provide him with some of the SEMs we did with our experiments there. He is wanting to take on and pursue the work of Takaaki Matsumoto. In other Japan news, the evaluating agency 9 Sigma has been removed as the evaluating agency for finding solutions to fixing the Fukushima tritium laced water, which is now standing at in excess, I believe, of 1.4 million tons, but they are dumping some of that into the sea. And I think part of the reason that a new evaluating agency has been found is that there's some friction between neighboring nations, and that new evaluating agency is Mitsubishi Industrial, as far as I understand it. I might get that wrong, but I think that's where it is. And they have an experience in low-energy nuclear reactions. So the net result of this, we are going to be reapplying, and I will be working with the team, providing them data and understanding for the proposals to be made to TEPCO via Mitsubishi. So that's really, really exciting. The paper that was came out of the work with Binzhu and Huang is now in third stage review in the world's 6th largest journal, that is Nature Scientific Reports. We don't know whether it will finally be accepted, but hopefully it will get to peer review. I don't know who the peers are that would review it, but anyway. So that's quite exciting. And obviously the work assessing the validity of Malcolm Bendel's thunderstorm generator is going on. I addressed the magnetic anomalies, and I was told again that one long cylinder had a stripe down it, and it was definitely stainless steel to begin with, and then it developed this magnetic stripe or ferromagnetic stripe down it. And I said, well, that's probably because the stainless steel tube was rolled sheet formed into a tube and then welded, and along the weld it is susceptible to this change of metallurgical state, probably from face center cubic to body center cubic, losing its non-magnetizable and non-ferromagnetic nature, and then being able to express some ferromagnetic nature. And so that would go for the other weld joints. Whether this is relevant, I don't know, and that is something to find out. But I think what you're going to learn during the course of this presentation, which will be just going over various bits of data, is that there is a strong indication that we are seeing something that is definitely due to plasmoids on a gargantuan stage level. And I'm going to walk through how you can know that they are probably being produced, and why they form into the arrangement they do, some historical data that points to the fact that this is known that they do this to a degree, and I will walk you through that now. So the first thing I would like to talk about is the analysis of ridge-to-ridge distance on fingerprints. And you might be wondering why. Well, you're going to find out in a minute. And that is because sometimes you can use things that are accidentally in your frame of reference to scale things. And I learnt this skill when I was doing lots of reverse engineering from photographs of 3D objects. So someone would send me a photograph, and there was, you know, an object in there they wanted me to build into 3D, but they had actually no idea, you know, what the dimensions were. And so I would look in the frame and see that there was a plug socket in the background, for instance, an English plug socket. And so from knowing the dimensions of the plug socket, I could work out exactly, or within a very good approximation, what the size of the object was that I was required to make for the client. In this case, I'm going to use this data, which comes from the US Department of Justice, to scale these objects that were captured on macro video camera using a Canon camera and a macro lens. And it's saying here the mean ridge to ridge distance for 731 measurements on the male subjects was 0.46 millimeter. So a little shy of half a millimeter, 500 microns. And why is this relevant? Well, if we are to assume that we want to create very stable exotic vacuum objects, I have argued we need to have at least a wheel within a wheel within a wheel. And that particular structure was derived from a structure that was on the MFMP's fracture sample, and it was approximately 1.6 millimeters across. At the sub-THOR level, it was hexagonal in nature, and actually looking at this structure now, you can see there's a kind of semi-straight line here and a semi-straight line. So maybe if this was in a different witness material, you might see a sort of hexagonal or polygonal nature to the overall structure. Certainly these kind of things produce these kind of polygonal type effects. Now, sometimes you see these ball lightning structures and sometimes you don't. So here is an example of a hemispherical one bound to a metal. Now, that may be a stainless steel bolt. If it is, then it's bound to that. But this is certainly nickel foil in Henk Uren's Vega experiment, and we have a whole sphere attached to that. So these things can bind to metal, and we've shown that they have substructure within them. I think the most important data point that we are going to draw upon in a little while is the work of Bogdanovich et al. At the Moscow Nuclear Physics Institute. And from the late 1990s and through the 2000s and into the 2010s, they had this plasma flow discharge system. And what that is they have a water jet with high shear onto a metal plate, and then they do high, in the multiple thousands of volts, discharges through the water vapor on the surrounding area of the stream. And they get a range of different plasmoid effects, and they actually refer to these as plasmoids. And some of the most interesting for me was a replication of what was observed by one of our followers, and we published on December the 4th, 2018 in a sort of Meccani type ignition secrets spark plug with this little structure here, and that was these clusters of clusters in a little ball moving around and spinning. And so they replicated that observation of ours collectively as MFMP, and they published in a major journal in 2019. What they also published is a toroidal type structure moving around for over 2 days. And this 2-day figure comes in a lot with stable exotic vacuum objects. And so we're going to look at one paper and then look at the actual data. So these are things I'm asking you to bear in mind. Some of you will have seen these things before, but it's the mean ridge-to-ridge distance for 731 measurements on the male subjects, and this long-lived plasmoid paper by Bogdanovich, Volkov, Len, and Nestorovich at the Moscow Engineering Physics Institute, the National Research Nuclear University in Moscow. So here is the schematic. We have our power supply unit on the ground plate and the high pressure water and the discharge through that. And they see black torus structures. They see pinch discharges. They see these spherical plasmoids on the surface of the grounded electrode post-discharge period. You saw the color image just recently of the time sequence of a glowing, luminous, long-lived luminous object coming out. And then this one is a luminous thread in the discharge, okay? And they've got a fattened end on here and a fattened end on here, and they say these are like monopolar or pseudo-monopolar ends. And so if these are able to bind to some metal, you would have a flux loop, okay? So if you think back to the video that first got me really interested in trying to verify whether this technology was valid, it was from the Thailand overdriven plasmoid generator, as he calls it, the thunderstorm generator, and there seem to be these flux loops coming in and out of the stainless steel. And so I argued what was happening is that these two ends were not able to travel through the metal, but the flux loop was able to travel through the metal. Okay? So that's that. And so I think if we look at figure 3, let's try and find where it's talking about figure 3. Blah, 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 blah. Figure 6, where does it say figure 3? Something. Figure 2. Is it going to talk about figure 3 or not? Somewhere. Anyway, it talks about that in this or another paper relating to it. Let's do a search. Can I do a search here? No, it's not going to let me do it. Okay. The other thing is, in this case, they had the body of the plasmoid, it would say, is going through this plate. Okay, so it's a separation of the plasmoid part, this bit, from its body. This is the body. So this, to me, looks like a torus, and this is the glowy bit. The torus and the glowy bit. Yeah? An object of weaker luminescence is visible on the other side of the plate, lower right. Okay? This, for me, is a wonderful piece of data. So that's kind of the points that I want to take out of this. Like I say, as ever, the references will be in the blog at remoteview.icu. So let's go back to our presentation here. So how I am looking at this is potentially this is one side of a north or south, or should we say a positive and negative charged plasmoid. But potentially a north and south. And that this is maybe bound to the inside of the outside, and these at the other end are bound to the outside of the inside. I'll show you a video in a little while where you will be able to see the spatial relationships of these things. And that maybe what you've got is you've kind of got like a hedgehog effect going from the inside sphere with like bits of like chewing gum stuck from the inside to the inside sphere to the inside of the outside sphere, and that the gases have to move through these flux loops. Is that potentially what is causing the very fast removal or cleaning up of the gases? I don't know. These are things for people to think about. Anyway, the reason I was asking for people to think about the fingerprint here is that either Malcolm Bendel or one of his accomplices has left their paw print, their fingerprint on this soot layer, and it really is a soot layer. And bearing in mind there is essentially no soot on the outside of the inside. It just doesn't look sooty. It's not black. But this definitely is black, the inside of the outside. And if you look, there are 1, 2, 3, 4, 5. Okay? That's one. So 1 gap, 2 gaps, 3 gaps, 4 gaps. That's 4 gaps. Now, what you're actually looking at with the black line here is the bit where the ridge of the fingerprint has actually not touched. So actually it's ridge to ridge to ridge to ridge to ridge to ridge. So that's 1, 2, 3, 4, 5 ridges. Across that is 5 ridges. So if we go to the data, the distance between the ridges was 0.46 millimeters on the average for a male. There was only one female out of all of the people that was interacting with this device. And I believe that the likelihood is that this is a male fingerprint. And therefore, we can say that it's between 1.5, maybe 1.7 millimeters. And why is that interesting? Well, that is interesting because, and what I mean is that this is one of these structures here. There's actually another one down here, and there's another one here. Okay, there's another one here. There's a bigger one over here. And so there are smaller ones and bigger ones, and we'll look at a whole range of examples of these in the video in a little while. And I will then pick up some images in Photoshop that I will show you the number of sides on these things. But anyway, this one is around about, let's say, 1.5 to 1.7 millimeters in diameter. And that, my friends, is very close to the one that was observed here on John Hutchison's sample. This one here, which was about 1.6 millimeters across. And so I would argue that these were stable plasmoids. And because they've got a very fixed position on the inside of this outer sphere, they are kind of locked into place. And we see this in the Vega experiments, that when you turn on the power and you turn it off, and you turn on the power and you turn it off, the plasmoids like to stay in a particular place. And I would suggest that this is because they've self-organized into an optimal arrangement, and then when they get re-energized, they start to there is effectively vacuum currents trapped in here, maybe etheric flows in there trapped in. And when they are energized with plasma coming out of the engine or so forth, then they find their home, and they start acting from that point. Now, the reason I talked about the Bogdanovich work and the thousands of volts involved there, I will refer you back to what I presented in the presentation that I gave as a rough hypothesis in Zurich, and that was about the Armstrong electrostatic boiler. And here it is, and I believe that the description is wrong, and that the steam, which is superheated steam in this reservoir here from this boiler down here, is injected into this water area, and it heats the water to an extremely high temperature, but it's still water. And that forces a bit of that water through this highly circuitous route in the nozzle, then through this capillary tube. And the combination of these two things creates hydrodynamic shear, extreme hydrodynamic shear. And this is multi-axis shear, and then very much toroidal shear as it comes through here. And as it comes out of the nozzle, it immediately flashes to steam. So you have a lot of vorticity coming out here, which is projected into the steam as it's released. And I think that's what produces a lot of charge separation. And that goes and fires off, and it's collected here. And because this is producing like 2-foot sparks, you're way more exceeding the amount of electric charge that is needed in the Bogdanovich work. And what I also noted on this particular device, this is an Armstrong electrostatic boiler, is that they have our sacred geometry structure round one way on one side and round the other way on the other side. So you have charge separation represented there. It's really rather perfect in the way that that is painted with this vortex ring structure. Okay, so I believe, therefore, that when the high moisture content water comes in and it flashes to steam, there's some charge separation there. That is the zone that we saw this sort of distorted part of the metal and potentially a magnetic anomaly in the large Perkins one that I looked at in London. And so then you have this high rotation charged gases moving around, and you also have the other ones coming from the inside as well at the other end, and they're coming out in the other vorticity, and the whole thing's kind of like metal. But the thing is, these structures, when they are in their non-radiating boundary state, this NR boundary state, they don't respond to electric fields and magnetic fields. But they do like to pair with the source of their what they like to feed on. And so I can see them getting bound to the metal and even maybe self-organizing through the means of the metal and grabbing electrons from the metal, but they aren't necessarily moved around by charge per se or fields per se. And we see this as presented in my presentation in Poland. So what will cause them to deplete is to have some kind of unfortunate grounding or connection between different parts of the thunderstorm generator, maybe, rather than a gas connection, more a direct to ground discharge path. So you may not get the build up, because what you are looking at here is the building to a point of stability, in my view. These are stable clusters arranged such that they can do work. Arranged such that they can do work. Okay? These, in Matsumoto's work, are clusters that were generated and they traveled through the water and they collided and impacted and left their mark on the copper plate. Now, one wonders if this was a nickel plate and then this nickel plate was used as an electrode in a Vega type experiment. Would we see the formation of balls of fire in the points at where these impacts had occurred? Because the metal is fundamentally changed because of the impact from the 1-point cold fusion discharge. I don't know. Anyway, we're going to look through a whole bunch of images here and some videos and see this in more detail. So just to recap, the size of these objects, in my view, is of the order of the size that were of the type that are very stable in the work of John Hutchison and in the work of Bogdanovich. Okay. And unlike the ones here, where you could say these are just kind of like, is this rust? You know, there was this whole debate, is this kind of rust? And is it just the way the rust forms? Well, that's not an argument you can make for the ones that you're about to witness, because they are the actual inside of the steel is not really affected. This is a change in the nature of the dusty carbon that's on the surface. And here's another point. We have found time and time and time again, for instance, the key from the event, from many other systems, that on one side you get carbon deposited and on the other side you get other elements deposited. And is that what we're seeing here, where one end of this chain, this structure where you've got this string between the two, is on the inside sphere and on the outside of the inside sphere, and the other one's on the inside of the outside sphere. So that's what I kind of imagine. I don't know if I've got my props here. If I've got my props, I maybe can explain it a bit better, but no, maybe not. Okay, so I'm going to go and get the video that I took these images from and show you that now. And then we can look at other... how should we put this? Can I go full screen on that? Window, view. Okay, all right, here. So I don't know if you can see this, but in here, this is, and unfortunately it was only caught in this particular shot. But not only do we have the black sort of circles, we also have these macro circles which have polygonal geometry. So this has like 8 sides to it. This is 1, 2, 3. There's probably 8 sides, or maybe 6 on this one. This has got multiple sides. 1, 2, 3, 4, 5. I don't know. It's got more than 6 sides on that. Then there are these little blue crystallite type looking structures, which again are hexagonal mostly. And then these ones, which we're going to have a look at a couple of others of that, and then these white little blobs. So I'm going to go through this. I don't know, there you can see down here, it's a little bit clearer. So these are much, much larger structures, and I wonder if these are clusters of clusters that have impacted rather than ones that are bound to the surface. So unfortunately, that's all you get of that, and I will share those images at remoteview.icu, and we then go back to the sample in a different position. And, you know, ideally you would want a tripod on a different rig so that you could really get in and see these things. So this is one nice looking structure here. It's probably not coming through very well at your end. But maybe I can adjust the exposure on that. Bring down the brightness a bit. It's not really doing it, is it? Contrast. Bring down the contrast. Okay, so we have other shots of this. So this has a yellow octagonal ring. In fact, I'm going to go in. This is 4K, so I can go into 200% here. We can see it closer. So this is very much a torus-like structure. It has 1, 2, 3, 4, 5, 6, 7, 8 sides. We've got this core yellow structure here. And then we have this whiter fuzzy area and a very whiter fuzzy area here, and then a sort of cleaner area in the middle. So this to me would be a toroidal structure that hit on the carbon and deposited something else there. One might argue what this is. I would expect potentially this to be sulfur, possibly. It would be very interesting to look at this particular structure. Okay, so I'm going to change the exposure there so that we can see the rest of this. So I'm going to fit this. Fit. And so we are coming up to the area where the fingerprints are. And so that's what I showed you earlier. So here we go. We've got one down here on the bottom left, center left, or sort of center lower part there. We've got another one here. That's the one I'm looking at. And then we go in. You can see there's multiple. So if this one is about 1.5 to 1.7 millimeters, this one's going to be a bit bigger. So we've definitely got ones in the ballpark of those observed on to the Hutchison sample. Okay. It is difficult to do this, and Kyan did a great job having never done this before. So I had various different cameras, and I will be showing some 400 times macroscopy of the shape of the crystals in the early part of next week. So look out for those. So there's a very white, large crystal here. Again, we're looking at fingerprints here. Same sort of thing. There is one there. If we can get that into focus. Yeah, there's there. Okay, so I'm going to go into 200 times here, which is the resolution of the actual capture here. And we can see this is it's hexagonal, but we've definitely got the torus nature to it. Very torus nature to it. Okay. And you can start to see the kind of what we call the leopard print on the other one. But we're going to look at these in Photoshop and do a little bit more basic statistics on it. In this one, you can see lots of them here. One there, one there, one there. And it looks like maybe there was layers. There's a big one here. So that one up there looks quite interesting. Is that the best shot we've got it? There, we'll take that one and go 200% and we'll go up there. So this is rather a large one, and you can see it's toroidal in nature. It's got the white ring around the outside here. Yeah. And then the dark thing in the middle. And then we can really start to see them here. Look at these. Beautiful, beautiful. Oh, look at that. That is very nice. So we're going to look at this in Photoshop, but I can tell you that there are definite hexagonal ones. Really, absolutely, definitely hexagonal ones. And octagonal ones, and so forth. So here, look at this beautiful hexagon here. 1, 2, 3, 4, 5, 6. Very, very clear. And these are the same things, remember, that we saw on the outside of the ball lightning burn in Henk Uren's Vega experiment. So the 15mm one, this one here. Okay, so on this was effectively a cluster that then instantaneously made this metal disappear. This is basically stuff going into a black hole, in my view, and it's created by a cluster of these structures, and we know from the edge of this it has a coherent boundary, which causes the that particular it's like an event horizon. It's total event horizon. Okay. And it was on the outside edge of here that we saw, of that little edge there, that we saw 2, 3, 4, 5, 6, and 8 sided structures. And it would be interesting to compare the scales, but I think these are a lot larger. So they're self-similar structures, but we will move forward here. So I'm at a big scale here, so I'll fit that down. So look at that, it's just lovely. Now, why is this really interesting to me? Well, I was sent a link to a paper because Eric Peterson, thank you, Eric, he found a paper that was written in 1992, and I have it here for your viewing pleasure. It's Force-Free Time Harmonic Plasmoids. Okay, Force-Free Time Harmonic Plasmoids. And you will remember from my ICCF 20 presentation, ICCF 25 presentation, that we had a clip of Tom Bearden talking about force-free structures. And this is by the author Jack Nachamkin. And if we look for ball, because why wouldn't you? And it says, the author believes that a number of observed phenomena, including ball lightning, fireballs, and charge clusters that occur in strong plasma discharges, may be described, at least in part, by the plasmoids in this theory. Some of the nonlinear effects of powerful lasers impinging on small spheres of material might also produce plasmoids of the type to be described. And here we go. In the introduction it says, Bostic, that's Winston Bostic, described a plasmoid as a structure made of plasma, whose form is determined by the magnetic field it carries along with itself. His definition attempted to describe the coherent discharges he encountered emanating from a plasma gun. These plasma structures are evidently very stable, have long lifetimes, and can interact with each other. Not electromagnetic fields, but they interact with each other. Since the time of Bostic's original work, plasmoid-like structures have been reported in other investigators. Who are we talking about? It's reference 3. Let's look at that later. Under different conditions, they may have names like anomalous discharges, charge clusters, and ball lightning. And here we go. Using standard wave model is not new. Kapitsa conjectured that ball lightning was explained by such a model having a vortical field structure. Oh, a vortical field identical to a component of an electromagnetic field is not new either. Wells explored such a model a number of years ago. What seems to be new is the combination of the ideas to explain some aspects of plasmoid phenomena. Portive fields that need to match stringent boundary conditions, but measurements are virtually non-existent. On the other hand, workers in Japan have produced plasmoids with exceptionally long lifetimes in cavities, sustained by microwave generators. Whether either of these examples can be described by force-free time harmonic waves remains to be seen. And so forth. Here we go. This value is larger than the average reported energies of ball lightning, and these excitations may represent an electromagnetically excited fluid state that could serve as a model for ball lightning-like phenomenon. So anyway, they're very keen to call plasmoids like ball lightning. And who is reference C? Let's just see who that is. Okay, that 3 is time harmonic. Schmidt, Libov, Smirnov, Nardi. Nardi worked with Bostic. This is in 1991. Who else we got? Is that it? Oh, that's just for that appendix. Okay, that isn't the overall references. Let's see. Let's look for references. Okay. Okay, so this one, this is the same guy that wrote this, Schmidt. Okay. Oh no, that is the same references. Let's go back. Have we got any other references? Okay, we've got more references here. So Bostic here. 3 is Taylor. Oh, Harold Puthoff there. Condensed charge technology and its potential impact on the electronics industry. Interesting. We've got Harold Puthoff there. All right, well, that being said, there's a diagram in here of what a spherical plasmoid looks like. Do you notice anything? Do you notice anything? Can anyone spot what I think I see? Do you spot anything on this plasmoid? Is it regularly spaced circles? Can anyone see any regular spaced circles? Am I seeing something that no one else can see? Yes, it looks highly familiar. And this is from 1992, my friends. And we know from the work of Leonid Aritskev, when a large ball lightning was formed above his exploding titanium foils in a metal chamber, that when they broke up, they formed lots of little small ball lightnings. And so it's a cluster of clusters. And there we go. I'm very good at seeing circles, yes. It's a special skill. Spherical plasmoid. Matching plasmoid boundary conditions at the surface of the plasmoid, electro and magnetic fields are parallel and tangential to the surface. This can be exactly matched by external vacuum fields. Okay? So, it's not surprising that you might get, if you can imagine this is the outside of the inner sphere with these regularly spaced structures, and the inside of the outer sphere with these regularly spaced structures. And then if you look at what I spoke about with Klimov's inflow plasma system, where he has a vortex and you end up with a different charge in the center to the outside of the structure, you can imagine if that vortex is going around a sphere, then you could have one set of charge separation, predominant charges on the outside, and the opposite on the inside. And so you might end up by separating the types of charge vortices that you create. And could that explain why you have these pattern structures on the outside of the inside sphere, but not a lot of carbon? And then on the inside of the outside sphere, you have this sheath of carbon, which has these marked structures clearly in the surface. So we're going to go back to the video here. So these dimples here, I believe, are akin to the structures that you see on this surface here. Yes, Conscious Energies is using the more recent term coined by the Sapphire project called plasma tufts, but these are not new observations. Yeah. So I think what we can safely preliminarily conclude is that these spheres are creating, along with the highly charged potential flash steam and the plasma coming out of the internal combustion engine, they are creating the conditions to forming long-lived stable plasmoids. Okay? And I think that's rather exciting, really. And as I said to you in the presentation on Friday, the lowest service curvature structures you can have is a sphere or a torus. And the sphere is probably the better of the two. And so that's what you have in this system. So moving on through here. And you can see these regular, very yellow spots. So are they sulfur deposits? Maybe. I don't know. To be determined. There's a nice white one there. If you can, oh, that's lovely. Look at that. We're going to zoom into that little puppy. Oh, yeah. Look at it. Oh, where did I go? Oh, no, I'm going through it. Oh, dear. I'm going through step by step. Oh, no. Come on. There we go. There we go. Look at that one. He's a nice little baby, isn't he? Look at that. He's got 1, 2, 3, 4, 5. It is 6. It's distorted. It's crashed into the surface. But that is really rather lovely, isn't it? We like that. So thanks again, Kyan, for manning the camera. Oh, there's our one there again. Can we get him in shot? I think we can, but we need to bring it down. Oh, look at this. Oh, look at this. Can you see what it is yet? Probably shouldn't do Rolf Harris. Let's have that one up. Where are you? Come here. Oh, I think we actually have a really good shot of this one. Yeah. It's like a donut, isn't it? Yeah, like that one. Oh, that's a nice shot of that one. Let's see if I can find him. Oh, yeah. It's got some real structure, this one. Look at that. Look at that. So Conscious Energies has said, hope you're able to put this to SEM. Keep up the great work, Bob. Thank you, Diadon. I have some samples that I scraped off. Are they in this drawer? Yes, they're in this drawer. But given the structures that I've seen in these macro, and also that you will see early next week in the 400 times microscopy using the trusty Samsung S7 and the Narugo lens, I think we need to take some sections, and I think I've got some tentative agreement from Malcolm to cut some sections out of that, and we will get them under the large format SEM, because I think it's necessary to confirm the spatial arrangement of elements in this kind of system. So what would be also useful is to do a deep survey of what areas over the entire surface of the inside of the outside actually has these particular structures in it. So Kyan's struggling to get the focus here. It's not easy. And that's up at the edge. Lots of little, very, very intensely yellow flecks there. This is interesting, actually. There's this whole structure at the top, but it could be rust in this case. May well be rust. But this is very, very sooty. Ah, this is a nice area here. In a second, I think he gets to it. He's trying to get to it. I'm showing you all of the footage here. Raw and nasty. It's handheld. Just the way it is sometimes. So there we go. Okay, so here. Okay. Right. Many, 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 many of these structures. So, you know, if you first looked at this, you might think that, it's just the influence of the crystal grains in the metal coming through, and, you know, you would just dismiss it. And that's why you kind of need to look deep. Oh, here we go. Look at this. This is lovely. Look at that. That is very, very nice, isn't it? Look at that. Let's go into that 400 times. No, I'll take it 200 times. So, yeah. Very, very nice. Look at that structures there. Beautiful. So it actually looks like you've got 3 bound together. We saw this type of structure on the inside fused quartz of Neil Crichton Gold's lion experiments. But here we've got a 1, 2, 3, 4, 5, 6. Very nice. Is that an 8? 1, 2, 3, 4, 5. Maybe it's a 7. I don't know. But 1, 2, 3, 4. Mostly 6 on that one. Very, very nice indeed. What a beautiful thing. Sometimes it's hard to hold your hand. Oh, he's got some even better shots here. Look at this. Look at that. Oh, look at that. Look at that. Well done, sir. Go on. In you go. Oh, look at that. There. Look at that. So, creating wares, did Malcolm mention why he didn't put exhaust back into system? Not really, no. I did say that will change the back pressure, and I said we obviously tests need to be run with the exhaust muffler on, and of course, because there's so many people that will be testing these. Just to let you know, there are several testing teams around the world, and he's going to be giving for free to the project a number of units. I think Martin's going to take one. I think so. You know, we will have an opportunity to test these things. But there are other groups, and they're already doing their preliminary testing. So I think we'll have a lot of data. The Germans have already done some work, and I'll have a little video on their build and their arrangement that they've got. It's already been published, their first sort of findings. Okay, so I'm going to pull up a few Photoshop slides here for you, and we can look at those. Give me a second. So first one is I did a composite of a couple of slides. It's not always ideal to do this because when you've got shaky cam, but here it is. So you can see a whole bunch of them here, but you've got a blurred bit in the middle here where it wasn't quite in focus. But you can't get the idea. Full scale is here. Okay, so I've got some other ones that I'm going to pull up, which I've just done a bit of statistics on it. So here, that's the original shot. Over here, what I've done is I've roughly calculated on here the number of sides on these various structures. And you can see by far the majority of them are 6-sided structures. But we have a couple of 5-sided structures, and we have a 7-sided structure over here. But the majority of them like to be 6-sided, it would appear. I think I've got another kind of composite shot like this as well somewhere. Is it this one? Yeah, kind of, but not really. Anyway, there you go. So some of them are rudely clear in terms of what they look like. I'm just going to adjust the brightness on this so we can see. So I don't think anyone, because they're taken at different angles and stuff, but I don't think anyone can argue that that is not a 6-sided structure there. 1, 2, 3. And I actually have a star tool here, and I can probably draw that on there, can't I? Polygon tool. I'll do 6 sides. Let's see if we can do that here. It's obviously the wrong angle. It would be, wouldn't it? Oh dear. Anyway, you get the idea. It's definitely 6 sides. 1, 2, 3, 4, 5, 6. Okay, definitely this one is 6 sides. 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4, 5, 6. Over here, 1, 2, 3, 4, 5, 6. Here, 1, 2, 3, 4, 5, 6. Think you get the point. 1, 2, 3, 4, 5, 6. So, is it something to do with carbon? I don't know. I think it just likes to arrange itself like this. And if you remember the Lendon Gledhill, I think, images, he took this ferrofluid and he took this beautiful magnetic fluid type structure that was the inverse of the Vega Valley. And if you looked at the actual ferrofluid itself, it organized itself into cells, mostly hexagonal, but sometimes pentagonal and sometimes multifaceted. So what you are seeing here is essentially what you see, like buckyball-like structure. I call this like a buckyball structure. And in a buckyball, mostly you have 6 and 5 sides, and that's what you see here. And there are the odd one that are 7 and 8 here. And I don't know what this one is, but, you know, so you get the idea. Yeah, kind of like the Giant's Causeway, says Stephen. Yes, very good. Wise to replay this at 2 times, Finn Bear. So that is kind of essentially it for tonight. What we have is we have a sphere. Oh, let me. There's a video where you can actually get a better idea of the arrangement of these things. Let me see if I can find that for you, because that would be useful, wouldn't it? Not that. Go here. Let me see if I can find that video. So we've got a whole bunch of very nice macro images looking at different angles and so forth. And microscopy images that we will share next week. Okay. I think this is the one. Is it this one? Right. It's this one. Now, Malcolm says, what's this? And I said, it looks like water has condensed on the top of the sphere here and then it's dripped onto the inner sphere, and then it's done a little loop around the weld and come down the other side. So you can actually see this, but it gives you an overview of the structure here. So water condenses here. Interestingly, it does have a sort of semi-geometric nature to it, and it drips from there onto the surface of the inner sphere here, and then it runs down in a channel. Okay. And the question is this sulfur rich? Is it collecting the sulfur in the moist air and then depositing it when it finishes? And it comes round this weld, and then it comes down under gravity and comes to this little spot here, and then it comes from here and drips off to the other side, down here. Okay? So I kind of solved that mystery within a few minutes of looking at it. But this is the outer sphere, okay? And what will happen is he zooms out here so you can see the overall thing in a minute. Okay, so when I'm talking about these things, I'm saying that this is the outer surface of the inner sphere, and so that was the stuff we talked about on Friday, and this is the inner surface of the outer sphere. So you'll see it in a little bit easier context in a minute. And if you just looked at this with your naked eye, you do not see all the things. You see these kind of metallurgical crystals, but you don't see these exotic vacuum object arranged structures on the surface. You just don't see it with the naked eye. And you see the little sparkly bits, and next week you're going to see what they look like under the microscope. But so that is the overall view here. So this is the inner sphere, outer surface, and this is the outer sphere, inner surface. Thank you very much, Crypto Alchemist, for your shout out on the alien scientist Salvatore Pi interview. Sorry I couldn't be there. Okay, and I think he does a pan back. This sort of ridging you see around here is part of the manufacture process for these objects. So yeah, you can see that condensed on here, dripped from here to here, ran up there, went around the seam, and then came down the other side. So mystery solved in about 2 minutes. You get it? You get it? You get it now? The question is this actually sulfur rich? And I actually have a bit of a regret now. I didn't actually take a sample of this, but if we do see sulfur and the rest of it, that will be interesting because it's one of the things you expect to see. However, you probably got sulfur in the things that's being burnt in here, quite possibly. So there we go. That is what you are looking at, the inner and outer sphere here of the thunderstorm generator. And the money shots really today are this is the inside of the outer sphere, and this is the outside of the inner sphere. Is this the same thing as Matsumoto observed? And what is that? Well, Matsumoto would argue that what we have is a black hole, and when the black hole explodes, it produces this expanding ring of something around it, and that produces a generation of a carbon film. So whatever goes into the black hole synthesizes a carbon film that comes out when it explodes. And in the point of electronuclear collapse, then you get a wormhole, and the stuff comes through the wormhole and comes out of a white hole. Definitely, or not necessarily, as the same elements as it goes in. And on the outer side of it, you have hydrogen, carbon, and oxygen, etc. And on the inside, you have titanium, iron, and so forth. So when we are looking at these structures, are we looking at titanium and iron and stuff in the center here in this structure? Okay, and hopefully the samples that I've got will see those elements, but really I need sections of the inside and the outside. So what are these white crystals? Are they calcium? Are they silicon dioxide? Is it got titanium and iron in these bits? Well, of course, you're starting with steel, so that's not going to tell you much. But if we see titanium in any large amount, you don't really expect to see titanium in this steel. It's not something you typically have in the steel. And then when it comes to the outside structures, what are we actually looking at there? What are these? And is this explosion of carbon? Is that what's, you know, what we're seeing here? So is the black hole on the outside here? Is that what's going on? But anyway, there we have it. All right. So if there's any questions, I'll take them now. Just another recap point here was that in this 1992 paper, if I can get to it, where's the 1992 paper? I would show you, but it's just Adobe Acrobat. It's terrible. Yes. Okay, I'm going to look through to see if any question. Is silicon it is silicon, Bob. Aluminium does the work. Well, it could well be silicon, but you know, there's the silicon and aluminium in very minute parts per million as additives into the engine. So I'm more excited if we find titanium. Titanium we have seen it produced in Henk Uren's Vega experiment. If you remember the prolapse where you had these two little discs coming out of the weak point in the geometry, and they had titanium in. So it'd be interesting to see if we see that. Could these points be discharging, fixed at one end, the outside sphere, and causing craters on the inside sphere? Yeah, so like the scale is different between the two, and it could be that the charge is going from one end to the other, right? So maybe this is the bit that's attached to the outside sphere and on the inside of the outside sphere, and it's continuously going through the gases and ejecting onto the inside sphere. Okay. Looking forward to finding out whether that is the case, and finding titanium there would be a good signature of that potentially going on. And if you take a lot of carbon and you make it into titanium, then, or iron, then you are able to capture a lot of nuclei in that process. Yeah, silicon, steel, fine. Yes, you have all those things, but this is why for me, titanium is one of the things I'm going to be looking out for. Right, as it's not come back, is it? It's just so terrible, isn't it? What a piece of software. Not responding. How original. So yes, we can have a look at these structures here, which we've given different numbers of sides to, and I will publish these images, and you can do your own analysis on them as you wish. But they think back here. Now, of course, when this paper was published in 92, and it's from the let's see who did this. It's University of Dayton Research Institute, and this is for the Phillips Laboratory Propulsion Directorate. Interesting. Air Force Material Command, Edwards Air Force Base. So this is work done at Edwards Air Force Base. And it says, a heretofore unexplored solution of Maxwell's equations is investigated for time harmonic waves in a partially ionized gas. The analysis is focused on the spherically symmetric cases that behave like electromagnetic energy trapped in the form of plasmoid. It will be shown that a critical frequency exists below which the current cannot be carried by electrons and the plasmoid remains stable. Resonant sizes will be shown to exist such that the plasmoid will not exchange energy with their external surroundings, and their boundary conditions can be met by vacuum solutions to Maxwell's equations. Virial analysis calculates free charge density and critical frequency to be consistent with Newtonian mechanics and classical electromagnetics. A stable vortical motion of the plasma will be shown to exactly cancel the dominant component of the electromechanical stresses, with the residual stresses being a strongly decreasing function of frequency. So this is work done at the Air Force Material Command at Edwards Air Force Base, and it's in the Propulsion Directorate. It's under the basis of the Propulsion Directorate. So they are literally looking at this from the point of view of it being a means to do propulsion. So what was the key thing that I wanted to pull out of that? Yes. Resonant sizes. Let's look at resonance. I mean, I really should have had time to look at this. So let's see. Resonant. Okay, it's only there. Summary. Spherical plasmoid having a resonant size. Only at a resonant size can the outward going radiation due to the fields at the surface of the plasmoid be nulled and the external fields be joined continuously to the internal fields. And an example is given showing that a 1 megajoule force-free plasmoid in a standard temperature and pressure atmosphere could be described with physically reasonable parameters. Since the field of the resonant cavity does not radiate, neither of the fields of the plasmoid can radiate. I think it would be interesting to look at the maths in here and see if the scales of the objects we observe on the inside of the outside sphere, or vice versa, the outside of the inside sphere, are one of these resonant modes as predicted by this theory. It will be shown that these external fields can be described by the resonant modes of a perfectly conducting spherical cavity. So what it's implying is a superconducting structure here. A superconducting structure. No. I'll look for size. Yeah. Resonant sizes. Finite sized. Which depends on the size of the plasmoid. Resonant size. Resonant size. Come on, give me a scale. Right size. The right conditions of size and frequency. Overall size of the plasmoid. Okay, maybe I will share the link to this, and maybe someone can calculate or find in the document the specific size that is claimed, or calculate a range of quanta that would comply with their hypothesis. All I can say is what you are looking at here is truth. This is what works. This is what works. Does their theory match it? Then it's good theory, or reasonable theory, at least for the outside. Because you know what? They don't actually describe how the inside works. They don't, other than saying there's something vertical going on in there. To be fair, like I said, I haven't read the whole document through, but I think we have a good understanding now of what's going on inside. So there we go. All right, so I'm going to say thank you very much. Buenas noches, dobre noc, good night. This was THOR, Outside, Inside. I am reasonably confident to say that what I captured on Wednesday of this week with a team of camera handlers, including Johanna and Malcolm cheering us on, was data, real data, physical data that points to the system producing plasmoids and them getting embedded in the spheres. And we know that these structures do work. They can transmute matter. And so there's a real good case for saying that this might actually do what it says on the tin. And with that, I will say thank you very much and good night.